All right, graphing logs. So a log is the inverse of an exponential around that line, around y equals x. So it has the same sort of shape, the same sort of curve. It's just actually happening on the side instead of up and down. So we're going to worry about the same sort of things, an asymptote, and instead of a y-intercept, we're going to care about an x-intercept, because every log is going to go like that, going to go like that, going to go like that. They will all go through the x. So we care about an x-intercept and then another point. That other point can sometimes be hard to find, but we'll talk about how we do it. All right, so graphing these, let's start off. Well, we can't take the log of a negative, so they're all 0. Can't take the log of a 0, so that's 0. And the log of 1 is 0. And that's because, okay, so we're trying to solve that guy. Only way to make him true is for x to be 0. All right, so then we're not going to be able to solve all these numbers for the other ones. But what is log 2 of 2? Log 2 of 2 is 1. It's a nice, easy number to solve. But log 2 of 10, because 10 isn't a base number, that's going to be ugly. We know it exists, it's just going to be ugly. It's like taking log 10 of 2, that's also going to be ugly. It's going to exist, but it's not going to be pretty. But log 10 of 10, we can do that. Then negative log 2 of 2 is going to be negative 1. So there you go. I have points. I have points that were really easy to solve. And what I'd like you to notice is that I found when x is 1, that's pretty easy to do. So if I can make this bracket equal 1, I'm on an easy track to solve it. The other one that was easy to find was when I subbed in the number that was the same as the base. So I made that bracket equal the base, and then that was really easy to solve as well. So they're the key things to remember. So now let's graph them. So the first one, well, when x is 1, y is 0. When x is 2, y is 1. And then we just follow his pattern. And oh, shivers. Oh, shivers. And we need to remember to put our asymptote in. X equals 0. So this one, because they're horizontal, vertical lines, it's x equals. All right, next one. So 1, and then when x is 10, y is 1. 1, 2, 3, 4. I can't even graph that one. So, but if you put your scale better, you would be able to. Once again, asymptote is x equals 0. And for the last one, I didn't mean to put my axes there. We're pretending this is my axes. Just get rid of him. So 0 and negative 1. So that guy is our reflection. Just like with everything else, when you've got a negative right out the front, that is a reflection about the x-axis, so he is a flipped. Okay, so for all those ones, our asymptote was 0. Because we hadn't moved left or right any. This one is all about the movement left or right. What I want you to remember is that this guy in the middle is telling you in the bracket if you move left or right. And you're thinking for your asymptote, what value of x makes that bracket equal 0? Well, x has to equal 1 for that to be 0, so my asymptote's at 1. Okay, down here, x is the only bit in the bracket, so what value of x makes that 0? 0. What value of x makes that bottom bracket 0? X equals negative 1. So there you go. I have asymptotes for all of those graphs now. And that's where we start any log or exponential graph, with our asymptote. So then the next one we want to find, always want to find, is your x-intercept. So your x-intercept is when y equals 0. So it's going to be hard to show the maths. We'll give it a go. So 0 equals log 2 x minus 1. Okay, anytime you see number equals log, you want to turn it into an exponential because it's going to make your life easier. So we turn him into an exponential, And then we can solve it because 2 to the power of 0 is 1. Add 1 to both sides, 2. So I know my x-intercept is going to be at 2. Cool. So I can do that for the next one as well. So 0 equals log 2 of x plus 1. Okay, now right now, because I've got two things on my right-hand side, I need to get that 1 over the other side first. So negative 1 equals log 2 of x. Now you have number equals log, so we turn him into an exponential. So x equals a half. And last one, so we have 0 equals log 2 of x plus 1 plus 3. Once again, we need to move that 3 over to the other side first, otherwise we're not going to be able to solve it. Then we turn him into an exponential, so 2 to the negative 3 equals x plus 1. So we're going to minus 1 off both sides, and 2 to the 3 is an 8th. So x equals negative 7 on 8. Okay, so there's all our x-intercepts. So we have 2, we have a half, and we have negative 7 on 8. Then we want to be able to find another point. The easiest one to find is making your bracket equal the base. So the bracket equal the log base. So for the first one, that means I want that bracket that I'm taking the log of to equal 2. What value gives you that? Well, x has to be 3 for that to work. The reason I do that is because if I sub it in now, y equals log 2 of 3 minus 1. Well, that's y equals log 2 of 2. And what is log 2 of 2? 1. So that's a really easy one to solve. Alright, we're going to do it with the bottom one as well. Okay, so for the bottom one, I want my base to equal my bracket. So for that to be true, x has to equal 1. Cool. So if x equals 1, and I sub that in, so y equals log 2 of 1 plus 1 plus 3. Well, 1 plus 1 is 2, so now I've got log 2 of 2 plus 3. And what is log 2 of 2? 1. So that just equals 4. So they're the easiest points to find when your bracket equals the base. But it's not always going to work. So for our middle example there, we want x, our bracket, to equal 2. No, he's going to work. He's fine. So that's it. The bracket equals the base. So then I sub him in. Y equals log 2 of 2 plus 1, which means I've got 1 plus 1, which is 2. There we go. So we've got the second point for all of them. So the first one, it's 3, 1. Hey presto, I can finish my graph. For the second one, it is 2, 2. Finish my graph. And for the last one, x is 1, y is 4. He's not drawn well, but that's what's going on. So they should all kind of look a bit like a curve. I've just drawn them really poorly. And so that's how we do it. So we don't need to use the table, but they're the three things we want to find. So here we go. First step, asymptote. Well, it is the value of x that makes the bracket equal 0. So negative 2. Our x-intercept, which is just when y equals 0. Alright, so first step we're going to have to get that 3 over the other side. So then I've got number equals log, so I can turn him into an exponential. So now I have 27 minus 2, so x-intercept is 25. So then the other point I want to find is bracket equals base. So for my bracket to equal my base, my bracket is x plus 2. Want it to equal my base, therefore x equals 1. So then I just sub that straight back into the original equation. So log 3 of 3 is 1. 1 minus 3 is negative 2. That's all the information I need. So then I can graph him. Okay, so asymptote is negative 2. X-intercept is at 25, so that's a big old one. And my other point is x is 1, y is negative 2. So while he is hard to draw, that's something like what it'd look like. And don't forget to label those points. Alright, for the next one, asymptote. Well, we haven't moved left or right because there's nothing going on that's been added to that 3. So that's really easy, x equals 0. Then we want the x-intercept. So 0 equals 2 log 10, 3x. I'm going to turn him into a power. So that's 3x squared. And now I have number equals log. So that's 10 to the 0 equals 9x. So x equals a ninth. Not a pretty number, but it works. And the last one, bracket equals base. Well, for my bracket, which is 3x to equal my base, x is going to have to be 10 on 3. Alright, so we sub him in. Y equals 2 log 10. 3 times 10 on 3. Okay, so 3 times 10 on 3 is 10. Log 10 of 10 is 1. 1 times 2 is 2. So that's another point. Alright, so x equals 0, a ninth, and then 10 on 3, which is 9 and a third. Sorry, 3 and a third, and 2. So he's going to be somewhere in there. And if you find that your x-intercept and your bracket equals base is the same number, the other one I would suggest you do is bracket equals 1. That's another one that's easy to do. Alright, so it's chapter 14H, question 1.